Okay, cool. So yes, let's talk about string hashing. This is again, I would say, a very cool topic, right? You can solve a lot of string problems using string hashing. And when I say this, what really happens is that, for example, if I tell you that this is a string, let's suppose this is a string. I ask you to tell me whether this string, this substring, or basically let's put it like this. Just a second here. This is S1 and this is S2. I ask you, tell me if S1 is equal to S2 or not. How much time are you going to take to do something like this, to evaluate whether S1 is equal to S2 or not? Let's suppose the length of both of these strings are M. How much time are you going to take to evaluate whether S1 is equal to S2 or not? Order of M, because both of these lengths are M? Correct. But in this session, I'm going to cover a very interesting technique known as string hashing, which is going to allow you to do the same thing in order of 1. In literally order of 1, yes. Okay. And not just this, string hashing is a technique which has a lot of other applications. It can be used in a lot of different problems. So ideally, first of all, we'll get started by talking about what is string hashing, what are the requirements, and how do you hash a particular string. Okay, so let's get started with that. And before we even get started, let's talk about, why are we using string hashing? Where exactly is this used? So first of all, it is a very cool technique to optimize brute force solutions. Okay, this is very important. It is a technique used to optimize brute force solutions. A lot of solutions that we'll be covering using string hashing can also be solved in a brute force manner. But if you use string hashing, they can be solved more efficiently, right? And the most common use case of using string hashing is to compare two strings. For example, if let's suppose this is a string S1. Let's suppose this is a string S2. Okay. I ask you to tell me whether, let's suppose this is a substring L1 to R1, and this is a substring L2 to R2. I ask you to compare L1, this substring with this particular substring, right? When I say compare, you basically have to check whether they both are equal or not. So string hashing doesn't really work on just a single string. Basically, like this, there can be different use cases. Let's suppose there is string S is equal to this string, right? Now, if I tell you to compare these two substrings, these two can be compared in order of 1 with string hashing. And if I have, let's suppose, two strings, S1 is equal to this, S2 is equal to this, then these two substrings can be compared in order of log n. Okay, all of these things we'll be discussing. How does this really actually, how does it actually work out? So don't worry about all of this stuff, but this can be done in order of log n, this same stuff, like comparing substrings of two different strings. Does that make sense, what I'm saying? In the first case, this is the same string S. On the same string, you have to compare two substrings. But in the second case, you have to compare substrings of two different strings itself. Okay, write a +1 if this makes sense, like what I'm saying. Okay, cool. And secondly, I would like to term string hashing as the daddy of all string algorithms. Let me list out some string algorithms here. KMP, Z, Aho-Korasik. Not sure of the spelling here, but yeah. All of these things, all of the things that are done by KMP, Z, Aho-Korasik can also be done by string hashing. I wouldn't say all, because obviously these algorithms have their own use cases. These are pretty advanced algorithms, okay? Very advanced algorithms. They have their own use cases, but in most cases, you would be using all of these algorithms for string matching. What is string matching? Comparing two substrings, comparing two strings, basically that same stuff. And that can be done very easily using string hashing. Okay, clear? The motivation is clear, right? Why do we need string hashing? Where are we going to use it? It's going to act as a replacement of a lot of algorithms, and it is going to help you optimize a lot of brute force solutions. Okay. Now let's talk about, what do I really mean by string hashing? Let's first talk about that. Let's suppose I tell you that, okay, I give you a string Priyansh. Okay. I give you a string Priyansh, and I map the string Priyansh to this number 1029. Okay. I have done this. I have mapped it in, I have logically mapped it, not used any algorithm to do it, but I've logically mapped Priyansh to 1029. Let's suppose I map TLE to 729. Okay. Now, if let's suppose another string comes, which is let's suppose TLE again. Okay. Let's suppose I ask you that, okay, I give you this as the first string, I give you this as the second string, and I give you this as the third string. For the third string, you need to check whether the third string has or was present in the previous strings or not. How will you do it? Can we do something like this, that we can just map this same TLE to 729 and then check whether 729 was present before or not? Can we do something like this? Yes or no? Yes. Right. So our idea here is to basically convert very, very long strings into small numbers. Okay, so that we can do comparisons, we can store them very, very easily. For example, if let's suppose you have this. Okay, let's suppose this is a very, very long string, this one, and you map this string to something like 29. Okay, now you got another very, very long string. You mapped it to, let's suppose, 34. Let's suppose you got another very, very long string and you mapped it to 57. Okay, now let's suppose I give you a query that I am giving you a string, this one. Has this string occurred before or not? How are you going to check? Can you do the same thing? You can map it to its corresponding number, to its corresponding hash. Let's suppose this number comes out to be 34. You can just check whether 34 has existed before or not. If yes, you're done. Does that make sense? Basically converting very, very long strings into small numbers so that we can play around with them. Has my screen freezed, by the way? Okay, cool. So, let's try to understand what are we doing. These are our requirements basically. If I give you a string A and I give you a string B, if they both are equal, right now we haven't designed a method to hash a string. Okay, right now don't worry about that. How are we finding out this number? How are we finding that the string, let's suppose this is Priyansh, TLE 1, 2, 3. Let's suppose this string gets mapped to 57. Right now, we haven't designed a method to map a string to a number, but let's just assume that the string has been mapped to 57. Okay, so now we are deciding on how to map a string into a number, right? And there are certain requirements for that. These are the requirements. If A equals to B, then the hash of A has to be equal to hash of B, right? For example, if I give you Priyansh, or let's suppose ABC, if I pass it through a hash function, this is, let's suppose, a black box hash, and outside the hash function, you get number 29. Okay, if I give it the string, let's suppose, BCA, I pass it to the hash function, and it returns, let's suppose, 34 for me. If I give ABC again to this hash function, what do you think should I get? If I give ABC back to this hash function, what do you think I should get? Ideally, I should get 29, right? Yes or no? Because the hash function is not changing. The hash function is a constant thing. See, it is like a very simple thing. You have a function here, right? There is an input and then there is an output. Okay. If the input remains the same, the output has to come out to be the same, right? Cool. Fine. So this is our first requirement. We are designing a hash function. Okay. Right now we are planning to design a hash function. How are we going to hash a string into a number? So these are the requirements. If A equals to B, then hash of A must be equal to hash of B. That's the first requirement. The second requirement is that if A is not equal to B, then hash of A must not be equal to B. Does that make sense? See, if I pass ABC to the hash function, if I get 29. If I pass BCA, I get 34. If I pass, let's suppose, DE, I get, let's suppose, 12. If I pass, let's suppose, Priyansh again to it, let's suppose I get 59. So what is my requirement? If I pass in two different strings to this hash function, I should get two different numbers. Does that make sense? Because obviously, see, if let's suppose ABC also maps to 59 and Priyansh also maps to 59, then what would it mean? It would mean that Priyansh and ABC are both the same strings, right? So should this happen, that both of these two strings should map to the same number? No, it should not happen. Okay. But in practical sense, it is not possible. Let me tell you why it is not possible. Let's suppose I give you a string S of length 50, or let's suppose length 100. Okay, I give you a string S of length 100, and the string only contains letters A to Z, the small letters. Okay. Tell me, what are the number of possibilities of strings you can construct in such a manner?
26 factorial.
Not 26 factorial. You can use A to Z for every single character, right?
26 power 100.
See, this is a string of length 100. For this particular character, you have 26 possibilities. For this also, you have 26 possibilities. For this also, you have 26 possibilities. For each of these characters, you have 26 possibilities. So you have 26 to the power 100 possibilities of strings. Now tell me one thing. What is the range of integers that you can store? Range of integers or range of long longs?
10 to the power 9.
10 to the power 18.
Integers are up till 10 to the power 9, and long can be up till 10 to the power 18. But how many different strings are we really talking about here for length 100? We are talking about 26 to the power 100. Are you able to understand what is the problem here? We have 26 to the power 100 different strings, but we want to map it to these many integers. It is not possible only to have different, a different hash value for every single string. How many people are able to understand this? 26 to the power 100 different strings, mapping it to 10 to the power 8 different integers or long longs. Not possible to have a different hash function for every single string. Right? So that is why what I have mentioned here is that we want this condition, but we want this condition to be true with a very high probability. We don't want it to be always true, but we want it to be true with a very high probability. Or in other sense, we want to say that we want this condition to fail with very low probability. Are you able to understand this entire thing now, guys?
I want to ask, can we use double or long double? Because
Sure,
their ranges are high.
You can use long.
Is low.
Correct. You can use, let's suppose, long double. So at the maximum, कितना ही चला जाएगा ये? If you understand, 10 to the power 100 तो नहीं मिलेगा ना आपको कहीं भी.
Yep.
You will never get 10 to the power 100. But the number of possibilities are just immense, huge. And right now, I'm just talking about strings of length 100. In competitive programming, you would have seen strings of length how much? 10 to the power 5, 10 to the power 6. So we are talking about 26 to the power these many strings. Can we really store them in integers? So many strings? No. Right? So now let's try to understand what do I really mean by it. Okay. Let's suppose I tell you these are your strings. Okay. Let's say I tell you there are 100 strings. Okay. You want to map it to 20 integers. You want to map these strings to 0 to 19. Are you all on the same page here? There are 100 strings. You want to map it to integers from 0 to 19. My question is, can every single string have a different integer for it? Yes or no? 100 strings हैं आपके पास और आपको सिर्फ 20 ही integers हैं आपके पास. Every string cannot have a different integer. Okay. Now let me tell you one thing. Let's do a probability type of thing. I pick up a string. I randomly give it an integer. Randomly. Okay. I pick up the first string. I randomly give it an integer. I pick up the second string. I randomly give it an integer. I pick up the third string. I randomly give it an integer. Are you understanding what I'm doing? Randomly giving, not designing any function. Randomly giving. So if I have a string, let's suppose ABC, I want to give it a number from 0 to 19 randomly. Can I say every single number here has the equal probability of coming? I am giving ABC to a random number, 0 to 19. So getting a number, let's suppose I tell you that ABC got mapped to 5. What is the probability that ABC got mapped to 5? 1 out of 20. Because ABC could have got mapped to 6 as well. ABC could have got mapped to 7 as well, to 19 as well, to 0 as well. Right? So can I say the probability that a string gets mapped, if I have 100 strings, and if I'm mapping a string to a random integer, then the probability that I get a particular integer x is actually 1 by 20. Can I say this? Yes or no? The probability that a string gets mapped to a particular integer x, the probability is 1 by 20. Okay. Now let's try to understand. There are 100 strings. There are 20 integers. Okay, mapping has to happen here. Let's suppose I give you a string ABC. Fine. And let's suppose I give you a string DEF. So give me a random number and for ABC. Give me a random number for ABC from 0 to 19. 0 to 19. Give me a random number for ABC.
7.
It is, Let's suppose 5. Let's take it 5. Okay. What is the probability that ABC gets mapped to 5?
1 by 20.
1 by 20, right? Cool. Now, let's say DEF also gets mapped to 5. What is the probability for that?
1 by 20.
1 by 400.
Let me tell you again. See, there are two events. ABC gets mapped to 5. What is the probability of this particular event? Just this one particular event. 1 by 20.
20.
Okay. Now this is an independent event, independent thing happening, okay? Not linked to ABC. This event ko hata do. We don't care about this event now. What is the probability that DEF gets mapped to 5?
1 by 20.
1 by 20. What is the probability that they both happen together?
1 by 400.
1 by 400. Cool. Now this was for a particular integer, right? This was for a particular integer for 5. Correct? So the probability that two different strings, ABC and DEF, get mapped to the same number 5 is what? How much? 1 by 400. Correct? Let's look at it like this. ABC, DEF both get mapped to 5. What is the probability? 1 by 400. What is the probability that ABC and DEF get mapped to 6? Both get mapped to 6. What is the probability? Again 1 by 400.
1 by 400.
So clearly, any two integers, or sorry, any two strings can get mapped to the same number with a probability of 1 by 400 when we fix the number. But there are 20 such numbers, right? So you can get mapped to any one of these 20 numbers. So the actual probability comes out to be 1 by 400 plus 1 by 400 20 times, which comes out to be 1 by 20. If you want to look at it in another way, let's try to look at it like this. 100 strings, 50 integers. Okay, strings, integers. 100 strings, 50 integers. Tell me the probability that string S1 and string S5 get mapped to the same single integer. Let's look at it like this. Let's suppose S1 gets mapped to any number here. Okay, let's suppose S1 gets mapped to any number here. What is the probability that S5 will get mapped to the same thing? 1 by 50. Look at it like this. Let's suppose S1 gets mapped to any number. Don't care about its probability now. Let's suppose S1 gets mapped to any number. What is the probability that S5 gets mapped to the same number? 1 by 50. So can I say something? Can I say this one thing? That doesn't matter how many strings I have. Let's suppose I have n strings. And let's suppose I have m integers. What is the probability that two strings from these n strings collide on the same number? Like they get the same hash value if I randomly assign a number. 1 by m. Okay, are we all on the same page here now? Talking about two strings, okay, picking up two strings from these n strings, what is the probability that they get mapped to the same number? 1 by m. As simple as that. Now tell me one thing. If this number m is large, would this help? Or if this number is small, would that help? We don't want collisions. Okay, we don't want collisions.
M should be large.
M should be large, yes. Yes, cool. Okay. Now, let's try to, look at the same thing. These were the requirements, right? Right now, we haven't designed a hash function, okay? We haven't designed a hash function, but we are saying this is a requirement. If A equals to B, hash of A equals to, hash of A has to be equal to hash of B. If A is not equal to B, then hash of A must not be equal to hash of B with very high probability. Does that make sense to all of you? Write a +1 if these two conditions make sense. And why the second condition has to have this probability concept behind it? Why can't it be true for every single case? That's important. Okay. The third thing is that calculating the hash function should be fast enough. Matlab, if you are requiring a lot of time to calculate the hash function, then why would you even bother calculating the hash function? Does that make sense? Like hash function calculation should be pretty fast, right? If you are taking a lot of time to calculate the hash itself, then why not just compare the two strings? Why even reduce them to their hashes? Okay. And yes, this is the fourth condition, which is very, very important. This is like, the first condition and the fourth condition are pretty much the same. If you are hashing a string, inside your code, the hash should not change. Okay. If you have hash, let's suppose ABC to 5, then in the code, let's suppose you want to find out the hash of ABC again, it should again give you 5. It should not give you a different number. Somebody saying, if I put my string into unordered map, will I be able to find it in order of 1? No. Why do you think you will be able to find a string in order of 1 in an unordered map? देखो string को compare करने के लिए string पे iterate तो करना पड़ेगा ना. If you have to compare a string, you will have to iterate on it. But once you hash the strings, then you can do it pretty easily. So that's the goal of this lecture. So don't worry about it. And the last condition is that hash value itself should not be very huge. Nah? Matlab, let's suppose I tell you, map ABC to this vector, 19, 20, 30, 40. Is this helpful? That map ABC, instead of mapping ABC to an integer, map ABC to this vector. Now, is this helpful? No, because this length was 3 here, this length is 4. Why would you even bother mapping? Okay, cool. So now let's talk about let's design a very cool, hash function which meets all of these things and which is known as a rolling hash function. Okay, let's talk about that rolling hash function. This is how we calculate the hash of a string, and this is known as a polynomial rolling hash. Okay, I'll give you 30 seconds to understand what this formula really means, and then I will tell you what, you just try to read it first, and then I will tell you what are P and M here. Okay. So if you were to take an example, let's suppose ABC is equal to, ABC is the string that is given to you, right? Let's suppose I tell you P is equal to 3, and let's suppose M is equal to 5. Tell me what would be the hash of this value. This is, if you understand this formula, you can tell me this value. Tell me the hash of ABC. Somebody saying, wait, but hash function will also iteratively work. I don't understand what you mean by that, Ayush. Can you unmute maybe? See, A is which letter of the alphabet? The first letter. B is the second letter. C is the third letter. Or if you were to take a different example, let's take D, E, F. So D is the fourth letter, E is the fifth letter, F is the sixth letter. So this hash function for this particular thing will be calculated like this. 4 plus 5 times P, P is 3, plus 6 times P square, which is 9, mod 5. Are you able to understand what this is actually meaning? We can change the hash value based on P and M. When we change the value of P and when we change the value of M, don't bother about what are P and M right now. But if you change the value of P and change the value of M, the entire hash of a string is going to change.
Excuse me, you are trying to say that D and F according to alphabets, right? 4, 5, and 6.
Oh, sorry. I think I missed out on that. So let me take an example, okay? We want to calculate hash of string S like this. S0 plus S1 times P. P is a constant, okay? P is a constant. P is not a part of an alphabet. P is a constant. Okay. Then we want to do S2 times P square. And we want to do it like this, plus Sn times, Sn minus 1. Because there are n letters in a string. So times P n minus 1. And you take the entire mod with M. M is also a constant. P and M are constant. Okay, are you understanding now what I'm saying? And how do you calculate S0, S1, S2? Basically, like, see, if you have a string like ABC, then A is 1, B is 2, C is 3. if you look at a string like DEA, then D is 4, E is 5, and A is 1. Basically, you are just saying which, I mean, you can't really, calculate this in terms of characters, right? If S0 is A, what does it mean in terms of integer? So you can just say that, basically map a character to its place in the alphabet. Somebody saying, but to calculate the hash, we will still have to iterate over the string. Yes, that's correct. You will have to do it once. But once you have the hashes calculated, then things will become very, very easy. So don't worry, like we'll go very, very slowly here. Have some patience and you'll see why this is useful. But is the formula making sense? Obviously, calculating the hash of a string will be order of n initially. Yes. Okay. So let me give you a problem here. Let's suppose the string is, A, E, D. Okay. Calculate the hash of the string based on the parameters that P is equal to 3, or let's suppose P is equal to 5 and M is equal to 7. Calculate the hash of the string. Let's see if you understood or not. I'll give you 1 minute to do that. (46 times 7), somebody saying. How do you calculate hash of AED? Hash will be, A is which letter? A is the, first letter in the alphabet. So 1 plus 5 times P plus 4 times P square mod 7. Which comes out to be 1 plus 25 plus 100 mod 7, right? Which comes out to be 126 mod 7, right? What is this value? So if you divide it, you get 1. So 0 आ जाएगा भाई. ठीक है, but yeah, 0 is also possible. Okay, so the hash of AED comes out to be what? 0. ठीक है, 0 is also possible. Like you can get, okay, tell me one thing. If you are taking the mod of any value from with 7, what is the range of values that you can get? If you're taking the mod with 7, what is the range of values? Obviously 0.
0 to 6.
Cool. Right. So do you all understand how this rolling hash function is calculated?
So this is
Yes.
the first problem.
Let me give you an exercise now. Let's suppose I tell you hash of string S is equal to, like, this string, this is a string, okay? String is equal to, let's suppose, H. Okay. Calculate the hash of string S plus X, where X is a character. Now you will see the magic in this. You are given the string of, you are given the hash of string S, which comes out to be H, and you obviously have the parameters P and M. P and M are constant for every string hashing algorithm. Then you want to calculate the hash of string S plus X. You just need to add the hash of X, yes, but the formula is going to be different. Let's see how does it differ. See. Yep. So hash of S is equal to what? S0 plus S1 times P, so on up till Sn minus 1 times P n minus 1. Just a second. Mod M. What is hash of S plus X? This comes out to be this same quantity plus X times P to the power N mod M. Can I say this? Yes or no? Now this value was already given to you, as what? H. So this comes out to be H plus X times P to the power N mod M. Correct? All on the same page here? Given the hash of a string S, I can calculate the string of hash S plus some character. Yes or no? Okay. It should be P n minus 1. Why? Why pn minus 1? Pn minus 1 तो already यहाँ पर आ गया ना. After that, if you add another character, that would be x times pn, p to the power n. X is a character, yes. That was already told here.
Shouldn't be only h shouldn't be mod. Only x into p to the power n mod m should be there.
Sorry, can you say that again?
Only x into p to the power n mod m should be there. Bracket shouldn't be there. I'm saying this.
How does it matter? Like, are these two things different? Are these two things different? No.
Okay.
Essentially, you want to mod it, right? Like if this value was 10 to the power 9, if this value also comes out to be 10 to the power 9, you would end up with 2 to the power 10, 2 into 10 to the power 9. So mod to पूरे पे लगाना पड़ेगा ना. So essentially, this is a better formula, this one. You could do that, but you will overflow outside the mod if you just add it. Okay, makes sense. Another question that I have for you now is, given hash of s is equal to h, what is hash of x plus s, where x is again a character and s is a string? Interesting.
H percentage mod.
Correct. Yes. I think you've got it now. So like it's pretty simple again. What is happening in my Apple Pencil? Hash of s is equal to s0 plus s1 times p, so on up till sn minus 1 times p n minus 1 mod m. But now you also want to add a character x, right? So it will actually become something like x plus s0 times p plus s1 times p square, so on up till sn minus 1 times p n mod m, right? So this essentially comes out to be x plus, like if this was h times p mod m. Clear? Yes or no? Somebody saying is x hash of x plus s equals to hash of s plus x. No, that's very obvious, by the way. Why would it be equal? Very obvious, but okay. So this is what we have basically covered. Yep. I hope both of these formulas make sense to you. So if I give you the string, if I give you the hash of a particular string, can you add a character to it and calculate the new hash? And can you add a character in front of it and make a new hash? Right? How much time will you take to calculate any of these? Order of 1. Not order of 1 exactly, because for this you will have to calculate p to the power n. For this you will have to calculate p to the power n, right? So this can be log n, because binary exponentiation you will use for this. But for this, you can do it directly in order of 1. I hope that makes sense. Like this is pretty elementary stuff. Why it would be log n in the first case and order of 1 in the second case. If you have p to the power n already calculated, then you can do the first thing also in order of 1.
Priyansh, but this is only possible when we already know the hash function, right?
I've already told you the hash function, right?
Yeah.
This is the hash function. You calculate the hash of a string like this. P and M can be decided. P and M, I will tell you how to decide. Don't worry about that. P and M are constants, but you understand the formula, right? If I tell you to implement a hash function right now, can you all implement a hash function? Right? With any random values of P and M. Okay. And do you also understand the point that this value can get mapped to any? Why is this function important? Why are we studying string hashing? I don't know. What do you want to ask by that question? Why is this function only the string hashing function that we are using, or what is your question? Yes, you could build a different hash function as well. There can be multiple hash functions, but a great part about rolling hash function is something that I will tell you now. why are we using this particular hash function? You could use a different hash function. For example, you could say that, okay, you have a string, this ABC, instead of calculating something like S0 plus S1 times P plus S2 times P square mod M. Do something like this. Just do S0 plus S1 plus S2 mod M. This is also a hash function. This is also a hash function. Right? So you can come up with your own hash function, but I will tell you why our current hash function is actually pretty good. Okay, why a rolling hash function works very well. Okay. Now let's talk about this one thing. How do you calculate the hash of a substring quickly? Okay. Until now, what we have done is we have calculated the hash function of a one given string. Okay. Let's suppose I tell you, do this thing. Calculate the hash of A, B, C, D, A, B, P, R, I, A, B. Let's suppose I tell you to calculate the hash function of this, hash of this value. How much time will you take? If this is n length, how much time will you take to calculate the hash function of this particular string? Order of n time, because clearly the formula has to iterate for n iterations. Okay, so calculating this takes order of n time. Yes, but now if I ask you to calculate the hash of this particular substring, how much time will you take to now calculate it? You will still take order of n time actually, because I haven't told you a method to do it quickly. Right now, I will tell you a method to do it very, very quickly. Once you have the rolling hash function, once you understand the rolling hash function, you'll understand it very easily. Now let's do one thing. Let's calculate the hash. Just a second, yeah. Let's suppose I give you a string S of length n. Let's calculate the hash of the very first character. What will be the hash of the very first character? Like I want to calculate, like if this is a string, I want to calculate the hash of this one particular character. What will be the hash of this one particular character? Basically S0 itself, right? S0. Right now, when I say S0, just assume that S0 is actually equal to S of 0 minus A, because I mean, that should be very obvious by now that we aren't dealing in characters, okay? We are dealing in numbers. Yeah, sorry, it should be S of 0 minus A plus 1 actually. Yes, correct. Because position of A is, we are treating it as one based indexed, okay? Cool. So if I tell you to calculate the hash of this one particular character, what will that be? And let's name it as hash of 0. Hash of 0 is the hash of the first character, which will be just S0. Cool. What will be hash of 1? When I say hash of 1, I want to calculate from here to here, the two characters. This will be simply what? S0 plus S1 times P mod M, correct or not? Can I also say that this is equal to H of 0 plus S times S1 times P mod M? Same thing that we discussed earlier. If I give you a string and if I wanted to add a character to it, how will you calculate the new hash, right? So instead of calculating the hash of just the entire string, we are going to calculate hashes of all the prefixes. Are you able to understand what I'm saying? We are going to calculate the hash of all the prefixes. Okay. Okay, let's look at it like this. So if I tell you what is hash of string from S0 to S of K, what will that be? Basically the hash of string from the 0th character to the kth character. This will be simply what? S0 plus S1 times P, so on up till SK, K minus 1 actually, times P to the power K minus 1 mod M. Yes, this term I treated as H of K. Okay, understood this? What if I tell you to calculate hash of S0 to S of K plus 1 now? Very simple stuff what we discussed earlier. It will be just H of K plus S of K times P to the power K mod M. How much time will you take to calculate h of k plus 1 once you have h of k. It's simply basically order of log k if you don't have p to the power k calculated. But what we can do is we can pre-calculate all the powers of this. Okay, I think there's somebody. Yep. What if I tell you that you already pre-calculate all the powers of this value p? Then you can do it in order of 1, right? Okay. Let's try to see how does this actually look in code, right? So just give me a second. Let me open my Sublime and I'll share my screen then. Okay. Yep, let me share my screen then. So what is our goal here? We're trying to calculate the hash of every single prefix of a string. Yep, I'll tell you how you can do this order of 1 part, yes. Okay, is my screen visible to all of you? Okay, let's define 2 parameters. Let's say int p is equal to, let's suppose 3. And let's suppose, or let's take a bigger number. Let's take int, and I'll tell you how to decide these values, okay? Let's take int p is equal to 50. And let's take m is equal to, let's suppose 102, okay? Something like this. 103, let's take. Let's define a string s is equal to this string. Okay. And now let's define a function. Let's take the string in string s. We can calculate the length on our own, and this can actually return, a vector of hashes. Like, or let's keep it here. Let's define long hash prefixes. Let's name it like this. Okay. And this function, what this will do is that it will just calculate hash prefixes. Okay, cool. So are you all on the same page here? What are we trying to do? We are trying to calculate the hash prefixes, basically the hash of every single prefix of a string. Okay, somebody saying shouldn't p be a prime? No, not required. I will come to all of these things, like how do you decide p and m? First of all, try to understand what is the use case of this. Why are we even calculating the hash prefixes? Because this is going to help us calculate the hash of a substring very, very easily. Do you all know the prefix sum approach that we use? If I tell you to find out the sum of a particular range, you can recalculate the prefix sums and then do p of r minus p of l minus 1. That is exactly what we're going to do here. Very, very similar stuff. Okay, so we want to calculate the hash prefix of every single prefix of a string. Let's find out the length. I mean, what I usually have is like some like shortcuts here, like sz is basically defined as the size of the string. Okay, so don't worry about all of these things, not important. Just focus on the actual algorithm. Okay, so let's do it something like this. We will have to iterate over all the elements in the string, and then let's first of all resize this, or yeah, let's do something like hash prefixes got clear. Okay, now hash prefixes has nothing right now, so that basically we can reuse this function. Okay, if we want to calculate the hash prefixes again for a different string. So right now I've just cleared it. Now all you have to do is you have to just iterate over the string and just keep accumulating the sums. Okay, so int I is equal to 0, I is less than n. So the character, basically, let's say int character, something like this, is equal to s of I minus a plus 1. Okay. Now what I'm going to do is I'm going to say that, okay, first of all, tell me if this is the hash prefix of the very first character, then do I need to do anything? I can just say that the hash prefix is that same character itself, right? So I can say if I equals to 0, then hash prefixes dot pushback simply character. Fine. But if I is basically not 0, basically if I'm looking at the second character, what will I do? You all remember this formula? Like h of k plus 1 is basically equal to h of k plus character times p to the power k mod m. This is what you are doing, right? So let's do one thing. Let's also pre-calculate powers. Okay. First, let's pre-calculate the powers. So this is what I was talking about, basically pre-calculating all the powers. So what I've done is that I've done something like this. Even if you want to do something like this, you can do it like this. Basically, powers of 0 is equal to 1. Okay, basically p to the power 0 mod m will be what? Just 1, right? P to the power 0 is 1. So somebody saying as it gives index to a like, for a it will be 0. So we have to, I don't understand what you mean by that, Sachin. You can maybe unmute if you want to. Why mod of power also? Because it can overflow, ना? p to the power 100 ले लोगे तो overflow हो जाएगा. Mod तो हर step पे लेना पड़ेगा ना, ये तो बहुत basic modular arithmetic है. p to the power n doesn't mean p to the power n. P to the power n means p to the power n mod m. Very simple stuff. Because भाई अगर तुम्हारा p लेट सपोज 26 है या फिर 30 है, उसका तुम लेट सपोज पावर ऑफ 100 ले लो, तो वो तो ऑलरेडी ओवरफ्लो कर जाएगा ना इंटीजर से. We don't want that. We want to keep the, ultimately the game is this only, na? Cool. So what we have done here is that we've calculated the pre-calculated p to the power k's, basically what we were discussing till now. Okay. Now all you have to do here is that, our formula was very simple. If I is, if you are looking at the very first character, then you just say that your hash is going to be that character itself. Otherwise, you just say that hash prefixes of I is equal to hash prefixes of I minus 1 plus character times basically powers of I mod m. Okay, let me bring this here. Just a second. Cool. Are you able to understand this now? How we have pre-calculated the hash prefixes for all the prefix of a string? And basically, I think we need to do something like this. Basically, because it is empty, right? Also, just in case if I miss a semicolon somewhere, just remind me, because I'm in the habit of using Golang now. So I am going to miss out on a lot of semicolons. Cool. So this is how it looks like. Right now, if I tell you to give me the hash of any particular prefix of a string, how much time will you take to give me that hash now? Just order of 1. And how much time is this entire step taking? This entire step, this void calculate hash prefixes. This is taking order of n time. So you are given a string, you are spending some pre-computation time to calculate the hash prefixes for every, for every single prefix. Correct. But now if I require the hash prefix of a particular prefix, you will require not order of n time, but just order of 1 time. Correct. Sorry. This should be correct. This is else. Yep. Thanks for reminding. Yes. Okay. Do you want to see how the hash prefixes look like? Like just running this code once. Let's try to just print these. Don't look at the actual implementation because that's not required. Like a lot of stuff I will be using from my own template, but at the end of the day, the algorithm should be clear to you. In level 3, we don't expect you to, we don't spoon feed you with the code. It is just that I'm doing it to make you understand how it really looks like. Okay, let's calculate. Why is this lagging so much? Okay, let's try to run this. Okay, there is some error here. Yes, this should be prefixes. Okay, there seems to be some other error. Has लिख रखा है मैंने, hash prefixes करना है इसको. Okay, so these are the hash values. Are any of them same? Like, if they both are same, okay, tell me one thing. If let's suppose the hash prefixes of two prefix come out to be same, would that be hash collision or not? A hash collision is having two different strings mapping to the same hash value. That would be a hash collision, yes. So can you see if there is a hash collision here? Somebody said there are two 88s. Are there two 88s? 188 is here. Oh yes, there are two 88s. See, this is a hash collision. Correct? So what would that mean? इसका मतलब ये होगा कि जो 4 लेंथ की string है, this is the same as this so much length string. Does that make sense or not? Like, this is a pretty bad thing, right? Hash values of two different length substrings are matching to the same value. But don't worry about the length. The idea here is to tell you that hash collisions actually happen in practical sense. Are the values same anywhere now or not? I don't think they're same. Nope. Are you now able to relate to that probability concept that I told you? That hash collisions, if you have a smaller value of m, are you able to understand? You are mapping strings into m integers. Very simple. Let's decrease the value of m further. And let's see if we have more hash collisions. Let's decrease it to 10. Let's see if we have more hash collisions. Okay, we have just one at every single place. I think that's primarily because 50 and 10. So let's make it something like 9. Don't worry about the values of P and M. I will tell you how to choose the good values of P and M. Okay. Now do you see hash collisions here? See, one coming here, one coming here, one coming here, one coming here. 4 hash collisions, and all of these 4 strings are different. We know for a fact that these are different. Right? So that's what I wanted to explain. Hash collisions can happen. But I will tell you how to choose good values of P and M, and I will tell you how to avoid hash collisions in the contests. That will be taken up at the end of this lecture. But for now, right now, you have to understand that hash prefixes are done. Okay. Now, if I tell you to calculate the, the hash value of a substring, let me open iPad again for this. Now you will be able to understand this concept very well. So you all understand the hash prefixes now? How we can calculate the hash, the hash of every single prefix of a string in order of n time. And then we can answer if somebody asks us to calculate the hash of a prefix, we can answer them in how much time? Order of 1 time. Okay. Now let's try to, modify the same approach and see how we can find out the hash of a substring very, very quickly. Let's suppose I tell you to find out the, like this is string S. You already have the hash prefixes calculated, okay? Assume that you already have the hash prefixes calculated. Tell me the hash of this particular substring. How are you going to calculate it? Let's suppose this is R, this is L. Give me a method by which you can calculate the hash of this particular substring. Not a prefix, but this particular substring now. Assuming that the hash prefixes are already calculated. See, what is h of R? Let's try to understand what is h of R. Hash prefix of R. What is that? It is simply equal to S0 plus S1 times P plus S2 times P square, so on up till S R minus 1 times P R minus 1 mod M, correct? Yes or no? What is h of L? S0 plus S1 times P, so on up till SL minus 1 times PL minus 1 mod M. What is hash of L to R? That is going to be SL plus SL plus 1 times P plus so on up till S, basically R, yes, times P how many are these? R minus L plus 1, right? So R minus L mod M. So don't tell me H of, H of R minus H of L. That is not going to work. Okay, tell me one thing. What is H of R minus H of L? Minus H of L. What is this quantity? Simply you have something like S0 plus S1 times P, so on up till SL minus 1 times P. Okay, let's not do this thing. Let's try to calculate first of all. Let's look at this first. Okay, so H of R is clear, H of L is clear to all of you, right? Basically, see, H of R is basically the hash of this particular prefix. H of L is basically the hash of this particular prefix. If this is R, this is L, right? We want to calculate the hash of this particular substring. This. Okay, very similar to what we used to do in terms of prefix sums. Just eliminate this part, right? We have to eliminate this part firstly. Yes. Let's try to first of all eliminate this part. So, let's try to calculate this value. H, why is this happening? H of R minus H of L minus 1. If let's suppose these were normal prefix values, right? If let's suppose you were calculating a normal prefix sum, how would you calculate the sum of a particular range? Can I say P of R minus P of L minus 1? Something like this. Prefix sum of R minus prefix sum of L minus 1. Yes. Let's similarly calculate the value of H of R minus H of L minus 1. What would this value be? See, H of R is simply S0 plus S1 times P plus so on up till something like S of L minus 2 times P of L minus 2, right? And so on up till S of R minus 1 times P of R minus 1. This is what? This is H of R. Okay, let's see what is H of L minus 1. What is H of L minus 1? Simply S0 plus S1 times P plus so on up till SL minus 2 times P of L minus 2. Okay. If you subtract out this quantity, basically, if you are doing H of R minus H of L minus 1, what would remain? That's the question. What would remain after this? If you subtract this, what would remain? See, all of this is gone. From here to here is gone. Basically, what would remain is something like S of L times P of L plus S of L plus 1 times P of L plus 1. So on up till S of R minus 1 times P of R minus 1. But do you want this quantity as your answer? You want S of L times P of 0, S of L plus 1 times P of 1, and so on. You want something like this. So can I say once I have this quantity, if I just divide it by P of L completely, I will get what I need? Yes or no? Okay, sorry.
Hi Priyansh.
I think it should be
L minus 1.
Yes,
that term भी बचेगा ना?
It should be L minus 1. Yes. Yes, correct. That's correct. Yes. Sorry. My bad. Okay, and this should be S of R minus 1 times P of basically how many characters are these now? This is a difficult quantity to calculate. Like this is P of R minus 1 only. But you don't want this quantity, right? You don't want this quantity. You want S of L minus 1 times P of 0. So what would you do? You would just divide this entire quantity by P of L minus 1. Make sense? Right? Okay. So can I say if I have hash prefixes calculated, prefixes are calculated. If I want the hash of a particular substring, then I can say just hash, like basically h of r minus h of l minus 1 divided by p to the power l minus 1 and mod m. This will give me the hash of a substring. Isn't this cool now? Given any l and r, we can calculate this value very, very quickly, right? Yes or no?
Yes.
How many of you know modular division? Like, this would require modular division, right? Because you're dividing now. So there is Fermat's theorem, like, right? Okay, cool. So we'll not get into all of this stuff. Just if you don't understand modular division or modular inverse, you can Google it after this class. But otherwise, also we'll have a class in of number theory in level 3, wherein we'll cover this stuff in advance. Okay. But the point here is that if you want to do something like a division, there is a restriction on the value of m now. Right? Has anybody learned Fermat's theorem in the past? Right? This quantity, like a to the power p minus 2 is congruent to 1 mod p, something like this. Right, just give me a second, I'll be back. I'll just take some water. Yep. So sorry. Okay, cool. I think, yeah, there's a bug here. So this should not be p minus 2, this should be p minus 1. So this is actually Fermat's theorem. So basically, in order to calculate the modular inverse of a, the modular inverse of a comes out to be a to the power p minus 2 mod n. Okay, for those of you who don't understand this concept, don't worry. This will be covered in level 3 in a lot of detail, right? But for now, just assume that if you have to calculate this value, let's suppose I tell you, calculate 1 by p mod, or sorry, let's suppose calculate 1 by a mod m. If m is a prime, then this quantity just is something like a to the power m minus. This should be m minus 2. This value. Mod m. Okay, for now, just assume that if somebody asks you to divide, if they tell you to find out 1 by a mod m, this is nothing but a to the power m minus 2 mod m. Okay, cool. So if you have to find out this value, like this, how will you do this now? You can just simply say that p to the power l minus 1, and now you take the whole power m minus 2 mod m, something like this. Very easy stuff. Okay, so now do you want to see how we calculate the hash of a particular substring?
Sir, could you please repeat this last part?
This modular arithmetic part, like how are we get?
Yes. How, like after divide, you said something.
See, what I'm saying is that if I tell you to find out a plus b, basically, let's suppose you have a and if you have b, okay. If you do something like a plus b mod m, you can calculate it very easily. Yes, you can do something like a minus b mod m also very easily. You can do something like a multiplied by b mod m very easily. How are you going to do a divided by b mod m? Right, so this is known as modular arithmetic, where you take the inverse. Right, so this quantity, if you do something like a by b mod m, this is the same as saying a times modular inverse of b times m. Do you understand this now? Modular inverse of b, basically. Okay, and this modular inverse of b is nothing but b to the power m minus 2, where m is a prime. So instead of you doing division now, you're just doing multiplication. eventually you don't want to do division, right? Why would you want to do division if you want to keep everything in an integer? So that's what I'm saying. If somebody asks you to calculate hash of a substring of L to R is something like h of L minus h of R minus h of L minus 1 divided by p to the power L minus 1, right? And you want to take the mod as well. But now this is a division. So what you can say is that if this quantity is A, if this quantity is B, just do something like A times B to the power m minus 2 mod m. Do something like this. Fine. Yes, for this m has to be a prime. So until now, what I was saying, what was I asking you all to do? I was saying that choose any values of P and M. But now doesn't it tell you that m has to be a prime? M has to be a prime right now. For you to do something like this, m has to be a prime. So can you give me a big enough value of prime that you should choose?
1e9 plus 7.
1e9 plus 7 is a pretty common number. You can choose that to be m now. Now, do you understand why do we choose 1e9 plus 7 as a mod, as a value of m, like in this hashing techniques? And what is the probability that two hash values get collided now? 1 by m. That's a very low probability, right? 1 by 10 to the power 9 is a very low probability. Correct? Okay. So now you understand why m can be chosen as 10 to the power 9 plus 7 or something like 10 to the power 9 plus 9 as well. Or you could choose m as 5 as well, right? Can I choose m as 5? Is this also a fine m? Like, can I choose it? Even though there will be a lot of hash collisions, I can still choose it, right? Why m has to be a prime? Because at the end of the day, you're doing this division, right? You can only map this division into this multiplication when m is a prime number. As simple as that. Okay, so that's why m has to be a prime and it has to be large. So you take 1e9 plus 7 or 1e9 plus 9, which is a large enough prime number, which is also an integer. Somebody saying, but pre-calculate powers is not possible now. Why? You can still pre-calculate powers, right? You will still need to pre-calculate powers to calculate hash functions very easily, very quickly. Right? Somebody say m is 1e9. M is 1e9, right? N is not 1e9. The number of powers are not 1e9. The value with which you are taking the mod is 1e9. The L and R you're choosing doesn't matter. Like, it's actually like zero-based index, to be honest. But I will show you this in code, so don't worry. Like, this is just the theory part. I will show you how this is calculated in code. Okay, everyone on the same page now? How you can, okay, tell me one thing. How much time will it take to calculate this quantity b to the power m minus 2? Mod m. This will take how much time? Log m time, correct. Because you're going to do what? You're going to do binary exponentiation here. Okay, cool. I mean, basically, you will not be doing b to the power m minus 2. You will be doing b like this to the power m minus 2, something like this. Okay, I hope that makes sense. Like this quantity p to the power l minus 1. For that, you would be doing m to the power m minus 2. Okay, let's look at it. Let's look at this same thing in code. Okay. So let me share my screen again. Just a second. Cool. Everyone on the same page here? Do you have any doubts before I begin with the coding part? Can you go through the p to the power l minus 1 once more? Let's code it and then we'll tell you. Okay. Also, let's do one thing, guys. Let's also, bring out this power function outside. Because for this, we will be using it again, right? This power function, we're going to be using this, power vector, we're going to be using it again. Let's just bring it outside, this thing. And now let's define a function. Let's suppose LL, substring hash. Let's call it substring hash. What it does is that it just takes integer L and integer R and it gives you the hash of the substring. Okay, we just want to write this function now. Fine. Okay. So now what we'll do is that what is the hash? Sorry, what is the substring hash? Basically, substring answer is basically something like h of r minus h of l minus 1 divided by p to the power l minus 1. Correct? This is what you want to do. Okay. So for this, the very first thing we can check is that if l equals to 0. Okay, I think I will be using if statements in a very wrong manner if I do it like this. So if, because in Go what happens is that you don't really have brackets outside if. So if l equals to 0, then we can just directly return hash prefixes of r, right? Does that make sense? This one. If l equals to 0, we're just talking about the hash of the entire prefix. So if l equals to 0, we can directly return the hash prefix of r. Okay, cool. Now let's calculate this value first. Let's call this a and let's call this value b. Okay. So let's do something like LL a is equal to hash prefixes of r minus hash prefixes of l minus 1. Okay. And what I usually do is that I usually write a function like mod add, mod sub, mod mul, and mod division. Okay. What this does is that it basically, like, let me just show you here. Basically, if I want to do hash prefixes of r minus hash prefixes of l minus 1, I will just say this mod sub of hash prefixes of r minus, sorry, hash prefixes of r, comma, hash prefixes of l minus 1. What this will do is that it will just give me the hash prefixes of r minus hash prefixes of l minus 1 and take the mod with basically m. Okay. So why I like to do something like this in my code is because I don't want to be using the mod operator at every single place in the code, right? Why would I want to do something like that? Because if I might have an overflow somewhere, then I will have to check at every single place where have I used the mod operator. But if I define the mod operator at just one place in the code, I will just have to check that one particular place to check if I'm having an overflow, right? Do you all understand why I'm doing something like this? Defining these addition, subtraction, division, multiplication somewhere else, so that I don't have to do them in the code. So basically the same thing, I can replace it with my own functions, but I've done it to just show you here. Okay. Now let's calculate b. B is equal to simply, you want to take, let's suppose, mod division 1 comma powers of l minus 1 and m. Okay. And then you just want to do something like, okay, let's do something like this. B is this. And you want to return a by b mod m. Correct? So you can just simply say return mod division a comma b comma m. As simple as that. Now, how is mod division happening? It is simply happening here. Basically, this. If you look at this function, mod division of a comma a b m, what is this happening here? Let's see. So we are returning the mod multiplication of a with the mod inverse of b. Okay, and what is mod inverse of b? It is calculated here. Basically, it is a to the power b minus 2 if b is the prime. I hope that makes sense. Like, this is some sort of abstraction. I don't want to show you exactly how we are doing it in code, because obviously, why to write all of these mod operators every single place? Right? If anybody has issues in this code, I can even write it like, here itself if you want. Basically, it's like saying, I want to calculate something like this. Mod inverse b, let's suppose. Okay, so this will be simply something like exponent of b comma m minus 2 comma m, right? And exponent function is just simply, it calculates b to the power m minus 2. This is a binary exponentiation function, which is a pretty standard thing. Okay, and then you just have to return something like a times mod inverse of b times mod. And you can also do it like this, but I've done it here so that it makes it a bit abstract for you guys. Okay, so the same thing is happening here.
You should do one LL in between A and mod inverse.
Both of these are already LL, right? These are not integers. Both of these are already LL. So why do any one LL in the middle?
Okay, got it.
Okay, so Ayush is asking, is 1 by P raised to the power L minus 1 mod M congruent to I think you'll have to speak up. I don't think I understand what you mean by that. I can write it on the iPad if you want, and then we can see if you're on the same page. So just give me a second. Okay, before that, let's first of all run this experiment and see if we are actually finding out the right hashes or not. Okay. So let's first of all, okay, tell me one thing. What should our value of M be now? We've already identified what the value of M should be. Tell me what it should be now. Can we say 1 plus 7? And let's define them as long so that we don't run into any overflows. Okay, for this value is fixed, right? Still to decide. This is still to decide how to decide. But this M is fixed, right? Okay. Let's do one thing. Let's calculate the hash of some substrings now. Let's first of all calculate the hash prefixes again. Okay, why is this taking so much time? Just a second. Does the resize function work like powers of, I don't know. Yep, I think they should work. Okay, so these are the hash prefixes, right? Can you find any two values being same here? Like very low probability, to be honest. But like 1 by 1e9, that's a very low probability of finding two hash values to be same here. Okay. Now look at the string and tell me any two substrings which are same. And we'll try to find out the hash prefix of both of these strings. Let's see. Let's actually modify the string. Okay, let's modify the string. And we'll find out two substrings which are same. ADCF, let's say, and we have another ADCF. So ideally, the hash of these two substrings, this one and this one should be same. Yes or no? Don't worry about all of these things, guys. Like hacks, all of these things. हम हल्के हल्के चीजें cover कर रहे हैं. I will tell you every single thing. But at the end of the day, the idea is that you should understand everything in the deepest possible way. I can tell you everything in just 15 minutes as well, but at the end of the day, you should understand why we are doing certain things, right? So do you all understand that this hash should be equal to this hash, like in the substring manner? Yes. Let's try to calculate it. So let's debug substring hash of the string from 0 to 3. And let's debug the substring hash from 4 to something like 7. Right, let's see. If we don't get it same, then we're doing something wrong. And we'll have to fix it. Okay, turns out these are different. So 0 to 3 is 0, 1, 2, 3, and 4, 5, 6, 7. Okay, what is wrong here? Let's see. So for the first case, we directly get 7557701, which is the same as this value. But for the second case, you're not getting this. Okay, what might be the problem? Murphy's law. So what is Murphy's law? Anything that can go wrong will go wrong. Let's see, what are we doing wrong here? if L equals to 0, return, yes. So if L equals to 0, then it is like saying, like we are saying that we want the prefix of the, we want the hash of the entire prefix, right? I think there is something that we've done wrong here. Let's see. Mod inverse of this should be fine. Is anybody able to spot any errors here? Powers of L minus 2. No, this should be powers of L minus 1 only. Let's see. Mod inverse also we are calculating fine. Somebody saying B is equal to powers of L. No. There is something wrong here. Why do you guys think that B should be equal to powers of L? Like some people are saying B should be equal to powers of L. Oh, okay. Okay, just a second. I think, yep, that you're actually correct. So basically we want S of L times P of 0, P to the power 0, right? We want something like this. But we're actually getting, like when we do something like hash prefixes of R minus hash prefixes of L minus 1, we actually get S of L times P of P to the power L, right? And we want to divide this entire quantity by P to the power L to get it, right? Okay, that's actually correct. Yes, that's correct. Good point. But did I write this wrong on the iPad? Just a second. Yes, I think there is some bug, so we'll have to clear it. But yes, you're correct. This has to be P to the power L actually. So I'll just when I share the slides, I will be sharing the different slides. Like I will fix this on the slides. I think this was my bad. So yeah, now these are same, right? Can you give me any other strings which are also same? Let's look at DC and DC here. Right, let's try to find out that. And let me take a moment and let me explain it just once again to you guys, like how are these substring hashes calculated? Because I know some of you would have gotten confused here. So we want to find out DC and DC, right? So this is 1 to 2. And this is 0, 1, 2, 3, 4, 5, 5 to 6. Let's calculate this 5 to 6. Both of them should also come out to the same. Okay, cool. Now, do you all understand this entire thing? Like, how are we calculating the hash of substrings? This should also be. Okay. What I'll do is that, after this class, I will also share the exact formula with you guys, like how it is represented mathematically, so that it avoids all the confusion. Because, I mean, I understand that in a live class, it can happen that we might have a one-off error sometimes. Like this P of L got converted to P of L minus 1 because of some confusion. But yes, it actually should be P of L. Right? If you want to understand like this, like basically what happens is that, let me just explain it here. H of R is equal to basically S0, so on up till S times R minus 1, S of R minus 1 times P of R minus 1. And this is taken mod M, right? Basically, this is what H of R is. H of L minus 1, on the other hand, is basically it goes from S0 to up till S of L minus 2 times. I think there is still some problem here. The first power should be 1 and not P to the power. Just a second. I think there is some bug here. What are you saying? Can you repeat this? The first power should be 1 and not P of L.
Hi, Priyansh.
Yes,
So
yes.
I was saying that first power when we are dividing HR minus HR HL divided by P to the raised to L minus 1, right?
Huh.
So the first quantity would still have P in P to the power L, right? We are dividing by P to the power L minus 1. So it would, let's say the power is 15. And then we are dividing by a lesser one, which will have a quantity, and that's why we are getting different hash. So if we divide by the same 15 divided by 15, the first quantity of power would be into 1. So that's my understanding.
I think there is some problem here. We've got confused in 1-based indexing and 0-based indexing, right? H of R actually means, okay, I think, yeah, we're actually confused in 1-based indexing and 0-based indexing. It should actually be S of R times P of R. Basically, this is what it should be. Yes. And H of L minus 1 should be this times P of L minus 1. And when we take the difference, when we do something like H of R minus H of L minus 1, we actually get S of L times P of basically L plus so on up till, S of R times P of R. But we want this quantity, the first one, to start with P of 0. So we basically divide this entire quantity by P of L.
Excuse me, what will happen if R equals to N?
R cannot be equal to N. R can only be equal to N minus 1 because R is 0-based indexed, right?
Oh, okay.
These L and R's are 0-based indexed. Okay. I think, guys, I'll just explain it once again on iPad so that you all understand what do I mean by it. I think we got confused in 0-based indexing and 1-based indexing. Right? So this substring hash will be H of L minus 1. Now divided by P to the power L. Okay. If you look at this, how many people are able to understand this part? This much. If L and R are 0-based indexed. Right? But when I was explaining this on iPad, we actually treated L and R to be actually 1-based indexed, I think. And somebody in the middle asked me that, is it 0-based indexed or is it 1-based indexed? And then I said it is 0-based indexed, but we actually took it as 1-based indexed on the iPad. Okay. So, but for now, you all understand the substring hash concept, right? How we can calculate the substring hash very, very quickly. Right?
Can you also represent hash of k in terms of hash of k minus 1 in 0-based?
Yes, sure. I will do it on iPad. Yes. Like if you want me to do it, if you have H of k and you want to represent it in terms of H of k minus 1, this would be H of k minus 1 plus P times k. Sorry, P to the power, this is character, times P to the power k mod m. Yep, this is how it would be. Right? I hope that makes sense.
Here k will be at max n minus 1, right?
Yes, correct. Okay, cool. So let me just go through it once more on the iPad and it will be a very quick revision. And then you will be able to understand this entire thing. And then we'll talk about how do you choose P, and then we'll talk about some pitfalls and some problems on string hashing. Basically, see, guys, this part, this calculating of hash prefixes and calculating of substring hash, you can actually templatize it. You don't have to code it every single time. You can keep it somewhere. You can code it first, verify it if it is working, and then just keep it for every single string problem, right? But at the end of the day, you have to understand how is this working. That's most important. Fine. So let me present my iPad screen again. And I'm sorry for the confusion, this 1-based, 0-based. It shouldn't have happened, but okay, cool. But that's what happens in a live class. You also make errors. Right. See, so what is H of R? This is R is 0-based index. Okay, when I said this is the string L and R, These L and R are zero-based indexed. Okay. So now if you look at H of 0, H of 0 is S0. H of 1 is simply S0 plus S1 times P. Similarly, H of R is going to be equal to S of 0 plus S of 1 times P plus S of 2 times P square, so on up till S of R times P of R. Okay. And I've written it wrong here. Let me just show you here. This thing is wrong. We were considering it as one-based indexed. So this was wrong here. Right? So what I'll do is I'll just modify the slides when I share them so that you don't have any confusion. But this is what we're actually talking about. How many people are on the same page now? That this is what is H of R in zero-based indexed. Okay. What is H of L minus 1 now? This is simply S of 0 plus S of 1 times P, so on up till S of L minus 1 times P of L minus 1. Okay. What is H of R minus H of L minus 1? This is going to be equal to S of L times P of L plus S of L plus 1 times P of L plus 1, so on up till S of R times P of R. So in order to find out the actual hash of the string from L to R, what will you do? You will divide this entire quantity by how much? P to the power L or P to the power L minus 1? You will divide it by P to the power L. Okay, cool. So let's do one thing. Let me just, entirely erase this part because I understand that this might have gotten confusing. So yeah, we were actually taking it as one-based index. This was actually wrong. Okay. So this is also wrong here. Just a minute. See, this is the part where you are actually doing correct. Like this is the actually N, right? This is how it should have actually worked. Just a second. This is actually wrong here, no? No. This part is correct. This part is correct. All of this we're getting confused. This part, all of this is correct. But here, when I was explaining the substring hash, this was actually wrong. Okay. So from here, we'll just erase this part. And what I'll do is I'll just take one more minute to go over this once again so that everyone is on the same page and we're not confused at all. This part is fine. This part is also fine. Modular arithmetic. This is wrong. This part is also fine. This is also fine. Yeah. Now this is the actual real thing. Okay. This is how things are working. H of R is clear to all of you. Zero-based indexed. S of 0 plus S of 1 times P plus S of 2 times P square. So on up till S of R times P of R. Similarly, H of L minus 1 is this. S of 0 plus S of 1 plus P, so on up till S of L minus 1 times P of L minus 1. When you subtract these two quantities, you will get S of L times P of L plus S of L plus 1 times P of L plus 1, so on up till S of R times P of R. But do you want this quantity? You don't want this quantity. You actually want this quantity, S of L to start with P of 0. Right? Then you want S of L plus 1 with P. And so on. This is what you want. So what will you do? You will divide this entire quantity by how much? P to the power L. Now is it clear? Substring from L to R is basically H of R minus, H of R minus H of L minus 1. भाई गाना कौन गा रहा है? Okay. Yeah, you divide this quantity by P of L. Okay, everyone on the same page now? How we have calculated prefix hashes, how we have calculated the substring hash. And this can work in how much time? This you can do pretty quickly, right? Cool. Now, there is also one more thing. You can see if you want to find out this value. What is this value actually equal to? Somebody has shared some screenshot. Okay, I don't know what is this. Yep. So if you are looking at this quantity, what is this quantity actually equal to? To this thing efficiently, I will share a blog after this class. And this essentially entire thing will drop down to order of